Okay, in 1.3, we're looking at graphing linear inequalities. So here it's not just a line, but it's everything above or below a line that's also part of the answer for these that satisfies this. And so it'll be shading. Make sure when you're watching these videos that you are writing all the work that I write out down in order to get the credit. So linear inequalities is not a function, because if I draw a line, it will cross it in more than one spot, a vertical line. But we can use linear functions to graph these linear inequalities. So if it is greater than or equal to or less than or equal to, if it has that line underneath, then we're going to do a solid line because we're including the line. And if it's greater than or less than without the line underneath, we're going to do a dotted line because we're not including that, but that's a boundary line, so it would come right up to it. So it's all the points right up to it. And we kind of, one place where you see it is with prescriptions or when prescribing medicine. A lot of times it's like anyone above this point, whatever data field they're looking at, or below this point, would receive this medication or this amount. Other things there are other things that we see this for even in a profit equation above that would be a profit. So we want to be able to graph these and work with these. So what we're going to do is you're going to, if it's not in slope intercept form, you're going to graph it like it's a line, and then graph it either solid or dotted based on the inequality. And then we're going to check a point, any point in there, and that's not on the line. And if it is true, when I plug in those X and Y's, then I'm going to shade in that area where that point is. And if it's not true, we're going to shade below it. We're also going to look at just some rules if it is in slope intercept form. So this is going to be a solid line because we're including the line in our answer. And so I'm going to treat it like we would a graphing a line. Since this is in standard form, we're going to use the XY intercept. So our x-intercept is when y is 0, so that's like it's not there. And we're going to divide by 2. So x equals 6 is my x-intercept. So I'd go to 6 on the x-axis. And then we're going to find our y-intercept by putting a 0 in for x. So then we just take our y term and solve that for y. So divide by 6. Y equals 2 is my y-intercept. So I'm going to go to 2 on the y-axis and put a point. So notice I'm not using a slope. I'm just picking my point. And then we said this is a solid line, so I'm going to draw a solid line. It's not very straight. And then I'm going to pick a point. Adjust that a little bit. Pick a point that is not on that line. So I'm going to just pick this point right here. That is the point 4, 3. So I'm going to plug in 4 and 3 into the inequality and see if it's a true. So if it makes the equation true. So I plug in 4 in for x. So I'm using this equation. And I'm plugging in 3 for y. And I'm going to see, is that greater than or equal to 12? So is 8 plus 18 greater than or equal to 12? Is 20 greater than 12? And it is, so I'm going to shade at that point where it's shaded, where that point is. So pause the video and try this next one on your own, and then we'll walk through it. But it's good to try them so that you can make sure that you understand it, and look back at the example. All right, so for this one, again, it's in standard form. So I'm going to go ahead and use my x-intercept and y-intercept. So x-intercept is getting rid of the y term and solving for x. So x equals 4. So I would go to 4 on the x-intercept. That's where it intercepts the x-axis. So there's a point there. And then the y-intercept is where it crosses the y-axis. And so I get rid of this 3x term here. And I would do negative 4y is less than or equal to 12. And then divide by negative 4. Well, I should say not less than or equal to, but equal to. So y is equal to negative 3. So I'm going to go to negative 3 and put my point. This one again is solid because of the equal sign underneath. I'm including the line in my answer. So I draw my line, and then I'm going to pick a point. I'm going to go ahead and pick the point 0, 0, because that is above it. So I would plug in 0 for x and 0 in for y and see if that's true. 0 minus 0, is that less than or equal to 12? Is 0 less than or equal to 12? And it is true. So I'm going to shade above or where that 0, 0 point is. If it is in slope-intercept form, which means it's y and then your inequality and your expression, your equation, then you can, if it's greater than, we're going to shade above, and if it's less than, we're going to shade below. Right below it would be less than. So this is already in slope-intercept form. So my slope is 1/2. My y-intercept is negative 5. So I'm going to go to negative 5 on the y-axis. And I'm going to do my slope up 1/2. This one is going to be a dashed line because we're not including the line in there, but it is a boundary. And then since it is greater than, I would shade above. And you could always pick a point just to check. Like if you wanted to pick the point 0, 0, I like that one because it's easy. Put in 0 for y and 0 in for x. And you have 0 is greater than negative 5, and that is true. So I could know that too. So either way works still. But if it is in slope-intercept form, then above is greater than is above, and less than is below. So I can always move things. Like here, I could move this 3 over here so that y is by itself. And then I get x plus 3 is greater than y, which also is the same as y is less than x plus 3. Notice I didn't change, I changed it the way it looks, but I still have the kind of the mouth of the inequality facing the x plus 3. So then I can graph that with slope-intercept form. So it crosses at 3, goes up 1/1. Again, this is dashed, so I'm not including it, and I do my dashed line. And since it's less than, I know it's going to be below that line. And again, if you want to pick a point and include to check it, you could also do that method if you don't want, if you forget at any time that it's greater than, it's above, and less than, it's below. Right, that's it. Let me know if you have any questions.